Okay, folks, welcome back. We're looking today at Mathematics Paper 1, 2017 from the EDEXCEL higher tier, non-calculator, as you can see from this big sign over here. Now we're going to try to go through as many questions as we can in the time that we have left. So, question number 1. The scatter graph shows the maximum temperature and the number of hours of sunshine in 14 British towns on one day. Okay. So let's have Salia join me on this question, please. Read the rest of the question.
For one of the points is an outlier. Write down the coordinates.
Outlier.
Write down the coordinate of this point.
So what does the word outlier mean, Salia? The one that's hanging, the one that's away from all the rest of the data. So if you look at the data, look at the data traveling roughly in this direction over here. This is all the data here. But we've got one point which doesn't really match, is far away from the data. That one's actually called the outlier. So if I get the color coding all right. So the outlier is the green one. So write down the coordinates of this point. So what's the coordinate of that point, Salia?
It will be 19, 10.
So let's have a look. So when we do coordinates, we always do along the corridor and up the stairs. So along the corridor, which means this way. So this point, we drop it down here, and we take it across here. So we got to go that way. So it'll be how many across?
Oh, will it be 10?
10 across.
And 19.
And then how much up will it be? 19? Yeah, because that's 10, 11, 12, 13, 14, like that, and that's be 18, 19. Okay, we got 10 and 19. Nice and straightforward questions just to start us off. It goes there for all the other points right down the top of correlation. So, okay, so Salia said it's negative. Let's have Lisa come in, please. Lisa, do you agree with Salia that she says it's negative? Is it a negative correlation?
I think so.
Okay, right. Can I have somebody who disagrees with these two, please? Put there. Yeah, join me, please. Let's have Abdullah.
Yeah, it's positive.
It's so the answer is no. It's not negative. It's positive. Okay, lovely. So the word we're looking for here is a positive correlation. Let me explain why it's positive. So basically, as the number of hours of sunshine is increasing, the maximum temperature is also increasing. So as one thing increases, the other one increases. That's called a positive correlation. A negative correlation would be if on our graphs, we had all the crosses going down the page like this. That would be called a negative one. Because it's going up, it's positive. Now, if we had the crosses going everywhere, what do we call that correlation, Salia? All over the place. No correlation. Lovely. So the current one is a positive. This one here would be negative, and that one here would be no correlation. So positive, lovely. Okay, good one. Okay, Salia, finish the question. See from please what to say.
On the same day in another British town, the maximum temperature was 16.4 degrees Celsius. Estimate the number of hours of sunshine in this town.
So we have to look at the maximum temperature, 16.4. So maximum temperature. Okay, right. Let me get rid of all these extra lines because that's going to just confuse things. Okay, let's get rid of all of this stuff. Okay, so it says 16.4.
Yeah.
So 16.4 will be somewhere along here. 16, that's 17. So 16.2, 16.4 is along there. Now, in order for us to work out the temperature, we need to draw a line of best fit first. So the line of best fit is like an average line that goes through as many points as possible and has as many points above as below. That's just our general guidance here. So everybody please have a go at drawing the line of best fit. For those of you who printed out the paper, I'm going to try to have a go myself. I'm going to use a clear ruler. Clear rule is good. Now the line doesn't have to be restricted to the dots. It can be a little bit bigger. Well, why is that? That looks like a funny straight line. Okay, let's try that again. Let me try the other edge of the ruler. Oh, that's nice. Okay, so there's my line of best fit. So now I'm going to get a different color. I'm going to go across at 16.4. I'm going to hit the line. And then I'm going to bring it down. Oh, oops, oops, oops. Okay, so this is 16.4 on this side over here.
It's 12.8.
Okay, degrees centigrade. And then that one's going to give us 11. That's 12.246.8. Mine's is roughly 12.9 on my one. Your answers will differ slightly depending on where you've drawn your line of best fit. So we're going to say 12.9 hours of sunshine.
Shall I carry on?
A weatherman says the temperatures are high on days where there's more sunshine. Does the scattered graph support what the weatherman says? Give a reason for your answer. So what would you say for that one?
Yeah.
So yes. Yeah.
Yes, the weatherman.
Yes, the weatherman is correct. Okay, give a reason for your answer. As the temperatures are higher, there's more sunshine. Let's have a look. As the temperature is higher, so basically as this one increases, and the answer is yes. That's the nature of it being positive correlation. That's right.
Could you say it is correct as it is a positive correlation?
Yes, the weatherman is correct because we could say here, as the temperature, because they've mentioned here, temperatures are higher. So we're going to use the word as the temperature increases, the number of hours sunshine also increases.
Sir, can you say that it's directly proportional?
Yeah, you can also say that as well, but we can put that in as well, because as the maximum temperature increases,
the number of hours of sunshine increases.
so does the number of hours of sunshine. Okay. Right, for question number 2, let's have somebody new. Okay, let's have Asadullah. Join me on question number 2, please. Express 56 as the product of its prime factors. So first of all, let's pick up some of the key words here. So, Asadullah, join me on this question, please. So, can you explain those three keywords to us, please?
Is a product that something times with something to give you 56.
And what's prime mean?
Prime, it's in its multiple.
So prime factor basically means a prime number that's also a factor. Okay. So factors of a number, the numbers that the number divides into. Now, what does, without leaving remainder, how do we go about this process? What do we do to the 56?
Do you do a factor tree?
We do factor tree. Well, I kind of tend to bring it down like this. This is the kind of the technique that I like to use rather than the factor tree as such. So first of all, give me some prime numbers first of all that we're going to be dividing by.
7.
Okay, so the first prime number is
7.
2.
2.
Then
3, 5, 7,
and so on.
No.
Okay. So when we're doing the product of prime factors, we have to divide by prime numbers. So the first one, now explain to the can you explain to us why 1 is not a prime factor?
Because it goes in everything.
That's not the reason. A prime number, to qualify as a prime number, to join the prime number gang or group, it must divide only by 2 factors. It must divide by 1 and itself. The number 1 divides by 1 and itself it's the same number. It has to be 2 unique factors. Like the number 2, it will only divide by 1 and 2. So it's divided by 2 separate factors. It can't be a repeated factor. So number 1 doesn't qualify because it has a 1 repeated factor, which is no good. You can't join the club of prime numbers. So we're going to divide it first of all by what?
2.
2. 56 divided by 2 is?
33,
20.
8.
Okay, and then we divide that by 2 again. That gives us?
14.
And then we divide that by 2 again. You keep on dividing by the same prime number until we can't divide it by 2. Now what do we divide it by?
3. Or 7.
Asudul, everything okay?
Yeah.
You want to divide 7 by 3? When does that one work for you before in the past? Okay, right. So now 56. So can you tell me what 56 is now as a product? So 56 is now what? 2 times by?
2.
Time by?
2.
Time by?
7.
Lovely. Now we can write it literally in that format, or you can simplify it and give it in his index format.
2 cubed times 7.
And that's what I would write down here for the answer. Lovely. So the question might sound simple, but you got to understand the key words: product, prime, and factors. Factors are the number that divide into the number without leaving remainder. Here we're talking about actually prime numbers, which are the factors, which is the 2s and the 7. Lovely. Question number 3. Let's have Madam Anaya come in with me to this question, please. Question number 3. So when we are doing a multiplication question like this, what are the special rules or special things that we need to take care of before we jump into the question and start multiplying it?
The decimal points.
Yeah, we look at the decimal points, yes, and we need to count what? Whoops. We need to count the number of decimal places.
Yeah, that's what it's called.
Yeah. Count the number of decimal places. Write this down. Whether you got the printout, you don't have the printout, copy the question. It only takes you 2 seconds. Write down the notes that I'm writing down in color. Okay, now how many decimal places do we have here? Now remember the key. Listen to my language, decimal places. I'm not talking about the points. I'm talking about how many places are generated altogether. How many do we have here?
2.
2. So we got 2 decimal places. That's place, not decimal points, decimal places in our question. So how many will we have in the answer?
2.
Fantastic. So this is what I used to write it down. Nice little kind of shorthand for that. So let's do the question now. You'll be surprised how many students doing a higher paper get this question wrong. Let's just hope we don't get it wrong today. Now there are many ways for us to skin a cat, or sorry, many ways for us to do this question. There's some of you use the grid method. You're all welcome to it. I'm not going to teach you 10 methods in one go. I'm going to do the traditional method, the method I learned while growing up as a young kid. So how do we do this particular question now? Let's go. Right, let's get a let's color code it. Okay, give me a second. Let me use the blue. So we need to multiply everything by what first on the first line?
3.
We multiply everything on the top by 3. Okay, so we ignore the 4 on the bottom. So go. So we got 6 times by 3 is?
18.
Don't take too long. 4 times by 3 is 12. 12 add 1 is
13.
12 add 1.
13.
Okay. I'm not trying to catch you out. Just listen carefully and breathe, girl. Breathe. Yeah. Okay. 5 times by 3 is
15.
15 add 1 is
16.
that's better. Okie dokie. Right. Next line. We multiply by the next digit. Second digit on the second line. But what do you put on first before we start the questions? What do you put in the box?
0.
A 0. You could put a star in there, an asterisk in there. You could even draw a little flower in there. I don't care what you do in that space. That space is not for any number to go in there that you're going to calculate. That forces the numbers to start here on purpose. That's the purpose. So let's go. 6 times by 4.
24.
Oops. I think I rubbed off too much there. Oops, 24. Let me get hold of the red again. 24. Good. And 4 times by 4 is?
16.
Add 2.
18.
Lovely. 5 times by 4 is?
20.
Add 1 is?
21.
21. Sounds like that joke. 21. Okay, lovely. Now, what do we do next?
Yeah, added together.
Okay, lovely. 8. I've got rid of the remainder so we don't confuse ourselves. 8. 3 and 4 is 7. 6 and 8 is? 14.
13. 14.
Yeah. 1, 1, 1 is?
2.
Don't
No.
forget
3.
the 1 on the bottom, 3, yeah? Okay, now here comes the part where you got to focus your brain cells on what we just said earlier. We said something earlier. You have to now put that back into practice. So tell me, what do we do with our statement, our highlighted orange bit in the beginning? We need to put the decimal points back in. Where does it go?
It goes before the 7. Right.
Okay, between the 7 and 8 or between the 4 and 7?
Between the 4 and 7.
Lovely. 1, 2 decimal places in the answer. Done. There's the answer, 234.78. Okay, out of all the papers I've marked in the past, you'll be surprised how many times I found this question done wrong, and the students were trying to line up the decimal points. They were doing all kinds of other crazy things with the decimals, and they haven't understood this lovely and beautiful basic rule of counting decimal places in and then counting them back out again for the answer. You don't need to do any jiggery pokery and you got to do this at the beginning and then you got to undo it in the end. No, count them back in again. Job done. Question done, and you got yourself there nice, lovely 3 marks. So the answer is 234.78. Just put that down. Okay, everybody else who's listening and watching, please make sure if we can make mistakes, we're writing wrong numbers down. If you make a mistake, can you please politely interject and say, sir, there's a mistake there. Can you please correct that? Because we don't do editing in videos. You need to correct it there and then so we can not leave any listener confused with the mistakes. Okie dokie, lovely. Thank you for that. And I think you're a little bit more nervous than anybody else. That's why all the little slips. But inshallah, I think as you get to more practice, you'll be fine, inshallah. Nothing to worry about. Okay, I think the next one's got Eliza's name written all over it. Please come and join me. Question number 4. Let's do this question. Okay. Read the question.
The area of the square is ABCD is 10 centimeters squared. Show that x squared add 6x equals 1.
Okay, so how many key words or terms are there in this question? So the key ones.
Area square 10 centimeters squared and show that.
Lovely. So when they mention the word area and they mention the word area of a square, these words are supposed to kind of like conjure up, or not just that, they're supposed to like your brain will say, yes, I know what that means. It's talking about this. So like, for example, whenever you're reading a book and you read certain words from the author, and then your brain starts imagining things based on that word, it triggers emotions. Now, mathematically, when you look at the exam paper, you have to do the same thing. When they mention the word area of a square, I want you to tell me what's the first that comes to your mind, Eliza, now? area of a square, what are you thinking about?
To work out the area of the square.
Which is what? What comes to your mind?
Base times height.
Okay, base down by height is one way of learning it. I mean, I like to use length down by width, which is exactly the same. So if you use base down by height, by all means, please use that. I like to use the base down by height for when you do triangles, because then you actually have a base and a height of the triangle in that sense. This is also base and height as well, but I just prefer this particular way. You can use your one, Eliza, you no problem at all. So area equals length times by width. Lovely. So what is the area, Eliza, in this question? What is the area?
10 centimeters squared.
Okay, so where does that go then?
Where the A is in there.
Okay, now, don't we normally put numbers into the formula like here, Eliza, normally?
Yeah.
We do. So what's happened in this question then? How come we're putting the number in the answer part? Why is that?
Because it's only told us the whole
Exactly.
area.
Because what they've told us,
Yeah.
normally we do normally put in L and W in, but in this particular question, they've given us the answer. So we got to put the answer where the answer goes. So the area value goes into area that goes here, goes 10. Lovely. Now, by looking at the diagram, what is the length of the diagram? I normally call this bit here, where's it gone? I normally call that my length. And I will normally call this bit my width. So what's the length? What is the size of the length? Because they're given us in numerical terms and in algebraic terms. How do we kind of like marry them together? What do we do?
Would we do 3 times x?
Ooh, that was close. Okay, let's have Abdullah. Can you help us in that part? If I want to work out the distance for length, the total length, can you give me something better than 3 times by x?
Oh, it's 3 plus x.
Okay, lovely. So Elijah, do you know why it's 3 plus x? Because we're working at the
length.
The total length. Total means add them up. So the multiplying bit comes in a bit over here. So our length is going to be 3. Whoops, let's get back to black. 3 add x. Here's your multiply, by the way. You know, the multiply comes here when you do length time by the width, but not when you're adding the length. Now, what's the width going to be?
3x. 3 add x.
3 add x again, because it's a square. Okay, it'll be identical. Oops. Okay, lovely. Now, they mentioned the word area, they mentioned the word square. Straight away, we thought about the formula. They gave us the value 10. We put the value 10 in the right place in the beginning, not inside the substitution, but as in the beginning answer part. And then he goes, show that. Here comes the next keyword. What do you mean by show that? What do you think it means?
Like the working out.
So not necessarily the working out. Show that means that's what they want you to get. That's the end value. That's the conclusion. They want you to arrive at x squared plus 6x equals 1. Obviously, you're going to show it in the process, but what they want you to do is to basically prove that equation is correct based on the area formula you use. So at the moment, I can't see any similarities between what they told me to show and where we're starting right now, but inshallah, it'll become a bit more clear as we go along through the question. Now, they're talking about area. What do we need to do with these double brackets?
Expand them, multiply them.
You know how to expand brackets?
Yeah.
Okay, go on then.
So would you do 3 times 3 and then 3 times x, which would give you 9, and then x squared. And then you do x times by 3.
Okay, well, hang on 1 second. 3 times by 3 is 9. 3 times by plus x is plus 3x.
Oh, yeah, sorry, plus 3x.
Yeah, and then you do plus x times by 3 is?
3x.
Again, plus 3x. Try, make sure you say the plus 3x, otherwise you'll have letters and numbers with no signs between them. That would be more confusing for you. What's plus x times by plus x?
Plus x squared.
Okay, plus x squared, lovely. Let's put the 10 back in. Right now we've got to get a 1 on this side, for example. Is on the right hand side, that doesn't matter. Don't get hooked on, oh, 1's on the right and I got my numbers on the left. You can do it that way as well. we need to get 1 on one of the sides. Now, I'll give you a clue. Can you see how we're going to make the 1?
Would you do 9 take away 10 take away 9?
Absolutely. You bring the 9 from the right hand side to the left hand side, becomes a -9, and the 10 minus 9 will give us
1.
okay. And then what's 3x add x?
9x.
Remember, you're adding them.
Oh, sorry, 6x.
Okay, and then what's x squared just by itself is going to be just literally x squared.
X.
So our question is literally identical to what they've got, but just so we got it on the other side, if you want to, you can just rewrite it again, same as x squared plus 6x equals 1. We're just turning it, putting them other way around, and we're allowed to do that mathematically. We just write equal on the other side. That's not a problem at all. Now, have we got to where they want us to get to?
Yeah.
That's what it means. Show that we've done it. Lovely. So show that is basically a proof question, but you got to look at the key words. Area squared 10. Write down the formula, put the 10 in, work out the length and the width from the diagram, throw that in, multiply it all out, rearrange it, and we're done. Fantastic. Thank you for that, Eliza. Okay, right. Question number 5, you got to work out the weight of this metal frame. Okay, Layla, please. Question number 5.
Okay. This rectangular frame is made from 5 straight pieces of metal. The weight of the metal is 1.5 kilograms per meter. Work out the total weight of the metal in the frame.
So what should we do first of all straight away?
Label the other sides.
Label other sides quickly from the information they've given us, because it's a rectangular frame. So there's the symmetry, but the length on the bottom is the length of the top. They're identical. Yeah. Okay, next. What's missing?
The weight of each metal bar.
No, what length missing?
Oh, the middle, the line.
Yeah, yes, the middle line. So that side's missing. We don't know what it is. So how do you reckon we need to, how would we work that out? And we're gonna give you a little bit of a clue that diagonal is part of a right angle triangle.
Oh. Do you have to find the area of the triangle?
Not the area at all.
Pythagoras.
The parameter.
Yeah, so we need to use Pythagoras Theorem to work out the orange side of the gray triangle. So even though they're talking about rectangular frame, he's got 2 triangles in there, and he's got a right angle triangle, so that should trigger off straight away. Right angle triangle, hypotenuse missing, straight away your brain should be thinking of Pythagoras. So let's write down. Now, Pythagoras Theorem is learned in different formats in different schools and different books and stuff. The format that I learned and that I've taught my students is a squared equals b squared plus c squared. Now, if I draw a little sketch of my diagram, the a is the most important side, which is the hypotenuse, and b and c arbitrarily is at your own choice. So my formula works with the a being and the hypotenuse and b and c being on the other side of the equation. That's the variation of the way the formula can be taught and learned in for the way we're going to try this particular question. So let's just jump to the question.
Okay. Your a squared is the question mark side, and then you do 5 squared, add 12 squared. So 25 add 144.
Right, let me just quickly grab this for the moment. I'm going to grab it, copy it. I'm going to put it down here, so then I can work on it from here. That's just my statement at the top. And now we're going to start putting values into. Okay, so what's my a? So the a is the question mark?
Question mark, yeah.
So question mark squared is equal to the b and the c. We can call this b and call this c. It doesn't matter which one you call which. That's your own choice. For the moment, b is 5. So 5 squared plus?
144. Oh, 12 squared.
Yeah, 12. Remember, we want to work out this length here. We don't want to work out the length squared. What do we do with the squared?
Root it.
We take it to the other side, and it becomes a root. So we have, let's get back to black. So the question mark is equal to the square root of 5 squared plus 12 squared. Okay, Solly, grab yourself a calculator, please. Everybody grab yourself a calculator. Don't shout at the answers. Everybody have a go.
Okay.
And then I want everybody to hand in their answers by Zoom. By your chat quickly. Okay, so nobody can see your answers anyway. So we're gonna do square root. Put it all in one go. 5 squared. Add 12 squared. Okay, equals. Okay, right. Okay, I'm getting some nice, lovely answers coming through. Fantastic. Everybody's got the same correct answer. Okay, so what did you get for that question, Layla?
169.
And the square root of it is?
13.
Fantastic. 13 meters. Okay, so we know now that's 13. Okay, so the weight of the metal is 1.5 kilograms per meter. So how many meters do we have now altogether, Layla, from our final calculation? What are we going to do now? We need to work out the total meterage.
You multiply 13 by 1.5.
Okay, now how many meters do we have, by the way?
Oh, all of them.
All of them. So come on then, give me the total of all of them. So you got 1, 2, 3, 4, and 5. Give me the numbers, please.
So you've got 24. The two 12s make 24, and the two 5s make 10.
Okay, you can do that way. I'm just gonna for the sake of explanation.
Oh yeah, I do it in the
Yeah.
way.
So okay, no, that what you're saying is fine, but I just want to kind of set it all out. So we're gonna work out the total by doing like that. So that'll give you 10, add 24. That simplifies to 10, add the 24, add the 13. So what does that give us altogether then?
47.
47 meters is the total.
Yeah, meters.
The total length of the metal frame. Okay, now we need to we still haven't finished the question. The question is still asking us, to work out the total weight of the metal frame is 1.5 kilograms per meter. How many meters do we have?
47.
So what do we do with that 47 then?
Multiply it by 1.5.
Multiply by 1.5. Now remember, this is not a calculator paper, so I want you to help me develop a method that would help us do 47 times by 1.5 easily without us having to break a sweat. So how would you do 47 times by 1.5 without having to get in a spot of bother? What do we do?
You divide it by 10, so that it's 4.7.
You could do 47 times by 1 and 47 times by?
Oh, half.
So we can do those two components. So 47 times by 1 is?
47.
And a half of 47 is?
23.5.
Fantastic. And then if you add them, combine them together?
70.5.
Okay, lovely.
Oh, yeah.
So on the answer on the line on the bottom, that's being given to us free of charge. Are we happy with that?
Yeah.
Lovely. Question number 6. Jazakallah for that. Thank you for that, Layla. That's nice, mashallah. Well done. Mr. Ismail.
Can we go back a second?
Of course. Hang on a second. Go on. Got that? Question number 6. Read the question first, please.
The equation of the line L1 is y equals 3x minus 2. The equation of line L2 is 3y minus 9x plus 5 equals 0. Show that these two lines are parallel.
Okay, so let's first of all look at the words. So they're talking about the equation of the line. So they're giving us two equations in slightly different formats. One's in y equals mx plus c, one's in a slightly different version of that. Now what's the key word here?
Show that these two lines are parallel.
Okay, so we've got lots of important words here. Parallel. So when they mention the word parallel, tell me, what are you thinking about in your head?
The two lines have the same gradient.
So the m for line 1 equals the m for line 2. So they've got to have equal gradients. Straight away, your brain should be saying, yeah, I know what parallel means. So let's have a look at L1. So L1, y equals 3x minus 2. How do you extract from that the gradient?
Yes, the number in front of the coefficient of x.
And how do you know that? Because the graph is already in the right, the equation already is in the right format. Yeah?
The 3.
So the m is the 3 here, the coefficient of x. So we can say that the gradient of line 1 is equal to 3. Right, let's change colors. Okay, so do line 2 on the right hand side. Let's start it off in its original format that they've given us. Now, what's a bit strange about this particular formula? What have they done different than the purple one?
They've made it equal to 0.
Okay, so they've rearranged everything from the
Yeah.
right hand side and then put it all together. Everybody's having fun on the left hand side. It's just not in the traditional format of y equals mx plus c. So how do you remedy that then?
You have to rearrange, so you do 3, so you subtract by 5. To
So you
get
have to
3
rearrange it and make what the subject?
y.
You have to make y the subject. Don't ask me why. You're gonna make y the subject, so we get it back into y equals mx plus c format. So let me just quickly highlight the y. Okay, let's get green. You want to make y the subject. Okay, now. What do I move to the right hand side then?
Minus 5. You subtract by 5.
We can grab all this kind of really.
Oh, yeah.
Just a little bit kind of like you'll be cheating a bit here. We're just kind of doing everything quickly in one sense because we're in the examination mode. So we said 3y is equal to opposite of plus 5 is,
9x minus 5.
and opposite minus 9x is
Plus
plus
9x.
9x, yeah? The plus I can take off, I'll put that there only for emphasis, we don't really need it. Okay, so opposite of adding 5 is minus 5. Opposite of minus 9x is plus 9x. So we've done really 2 steps, but we kind of showed it in one go, but it is still really 2 steps. Right, what's the last step now?
Divide by 3.
So opposite time by 3 is?
Divide by 3.
Okay, so now we're going to have y equals 9
3x.
over 3x minus 5 over 3. So simplifying that, so that's 1, that's 3. Y equals 3x minus 5 over 3. Then we grab our template and we match it underneath and it links up nicely, mashallah. So what's the gradient of line 2?
3.
So the gradient of line 2 is also equal to 3. So let's make a little statement as a show. So we can say since, come on, give me this wording.
Since since 2 parallel lines have the same gradient.
Okay, we can say since line 1, since the gradient of line 1 is equal to the gradient of line 2, therefore the 2 lines are parallel.
Parallel. Yeah.
Lovely. Since the gradient of line 1 is equal to the gradient of line 2, i.e. the gradient of line 1 equals the gradient of line 2 is equal to 3. Therefore, L1 and L2 are parallel. Okay, I'm going to leave it there for a moment for everybody to copy that down. Yeah, that question might. Okay, copy that down. I've color coded it for you. The purple bit is the line 1, the blue bit is the line 2. Then we have a final statement at the end. So even though the question kind of looks quite harmless and it's still quite a bit of thinking, what are they talking about? Show. So the show is like we have to kind of prove that it is, but it's not like proof in the traditional sense where you've got to go through like a lengthy process. So you've got to know what parallel is. Parallel means equal gradients. You have to extract the gradient information from the question. Okay, that's lovely. Thank you for that, Ismail. Okay, quickly, has everybody finished copying that down? Yes. Put a thumbs up next to your name if you finished all that. So I know that you're ready for the next question. Yes, yes, yes. Okay, good. Okay, lovely. Okay, mashallah. Okay, question number 7. Oh. Right, Abdullah, please. Sorry, you doing right. Abdullah, no, join me number 7.
Okay. There are 10 boys and 20 girls in a class. The class has a test. The mean mark for all the class is 60. The mean mark for the girls is 54. What would the mean mark for the boys?
Okay,
Work out the
lovely,
mean mark.
lovely. So let's try breaking it down. Let's look at the key words again. Let's look at the key words. So we got like numbers like 10. We got key numbers. So we got mean for the whole class, and we got the word mean for only for the girls. Okay, so what is this question talking about when you mention the mean? What does that word? What does the word mean to you? Abdullah. Okay, that's a nice one.
All of them added up and divided by how many they are.
Okay, lovely. So in your brain, you're supposed to be thinking for the word mean is the total. Oops, I don't know what I was doing there. It looks like Mandarin or something Chinese. Total divided by the number of values. That's what the mean actually is. So let's set ourselves up for the first part. So let's color code it as well. So if you want to work out the mean of the class, here we go. Mean of the whole class, okay, is equal to the total for the whole class divided by how many people in the whole class? Abdullah.
30.
30. And what's the answer to that?
60.
Okay, lovely. Now, so we know the mean. So they've given us the answer and part of the question. So are you able to work out for me the missing total here for me?
Yeah.
Go on then. How would you do that?
You cross multiply, so it'll be 60 times 30, which is 1,800.
So the total for the whole class is equal to 60 times by 30. 6 times by 3 is 18. Add on the 2 zeros. So we got that lovely value there from that information. Okay, now, what about the next bit? Let's change the color so we keep it. So we're going to work out the mean for the girls now. So the mean for the girls is equal to the total value for the girls, which you don't know. Total girls score. Girls score divided by, how many girls are there?
20.
20. And what was the girls mean?
54.
54. So what do we do here again?
Cross multiply, so 20 times by 54.
So, okay, where's my pen gone? Hello, Pepper. Okay, so we have the total girls score is equal to 54 times by 20. What's 54 times by 20?
1,080.
Fantastic. So 1,080 is the total score for the girls. For the whole class is 1,800. So how would we unpack the information about the boys? What do we do now?
Would you just take them away?
Take them away. So 1,800 minus the 1080. What's 1,800 minus the 1080?
720.
So 720 will be now the total score for who?
For the boys.
Total boys score. Okay, is 720. Now they go work out the mean for the boys. So the mean for the boys is equal to the total for the boys divided by the number of boys. So what's the score for the total score for the boys?
It'd be 720 divided by 10, which is 72.
And where do you get the 10 from the beginning of the question?
10 boys, yeah.
That's right. So there's 10 boys. So boom, boom, cancel off the zeros. So the final answer here is 72. You can write 72 marks. Work at the mean mark for the boys. Okay, if you don't write the word marks on there, you won't lose marks, but just it's a more complete answer. Okay, right. One last question quickly. We squeeze this in the last minute or two before we I think we stop the video here for the first 8 questions, and then we'll do those questions again and some of the other work as well. I'll give you that. Just give me a moment. Oh, Saleh, is this question for me?
Yeah.
Okay, Saleh, join me on this question. Question number 8. I'll leave the top bit of the top ones all to copy up if anybody is still copying. Sorry about that. I'm moving a little bit fast. Okay, so I'll read question number 8 for me, please.
Write 7.97 times by 10 minus to the power of minus 6 as an ordinary number.
Okay, so how do we change this particular? Well, actually, how do we change this into a normal number by using this?
You would get the decimal point and move it to the left hand side 6 times.
Okay, 1, 2, 3, 4, 5, and 6. Drop the decimal point down. Copy, copy, copy. Fill, 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 and fill with zeros. 1, 2, 3, 4, 5. And what do we do at the front of the number?
You put 0.
You put an extra 0 for good measure, so the number will then read correctly. Even though when we talk to each other, we can use the words in our spoken language. Oh yes, I've got, or he won 0.3 of a million in the prize draw. When you write it down, you would never write down 0.3. You'd always write down 0.3. So that's just a matter of mathematical etiquette that's how we do it. So that's our answer. Lovely, lovely answer. Well done. That's done. Okay, and that answer should really be copied up over here in the correct place. So we've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 7, 9, 7. Okay, we happy with that?
Yeah.
Right, next question now.
You would have to work out the value of 2.52 times by 10 to the power of 5. Divided by.
So what could we do first? We could actually rewrite the question in different form, in like a fraction style. And I'm going to now color code for you 2 different colors, so of the 2 different calculations that you will need to. Okay. Now in one sense, actually, let me just rub this out. I can actually do the highlights slightly shorter this way and not even include the multiplier. So when you're working out that calculation, you need to be thinking about the green part and the orange part. You have a numerical part of the calculation, and then you have the indice part of the calculation. So you will get 2 answers, and we have to put them back together again. So what's the answer from the green part? Just do bust up.
Okay.
So you got 2 points. Remember, this is a non-calculated paper, so we can't rely and just jump on the calculator because we can't use it.
0 decimal and 2 remainder with a 5.
So 4 times by 6 is 24, remainder 1. So this green part yields 0.63 times by now. Don't anybody jumping. I haven't finished. We're going to do some corrections onto as well. What about the orange part? What happens when you divide them?
Minus the,
so you do 10 to the 5 minus the bottom number, yeah?
Which is 8.
10 to the 8, fantastic. 10 to the 8, lovely. Now look at the answer. Is the answer standard form? It looks like standard form to me, but is it proper standard form?
No, we have to put the 6.3 times by 10.
Lovely. We have to do 6.3. 6.3. Give me a second. And then it's going to be times by 10 to the power of
9.
Now be careful. From here, we're going to have to jump 8 jumps. If you move it one closer, you'll have 1 less jump to do. 6.3 times by 10 to the 7. So that's our little adjustment to make it from a lookalike standard form to a proper standard form. So it's 8 jumps from its original position and 7 jumps from the new position. So our final answer is 6.3 times by 10 to the 7. That's where we're going to end this particular video because we've run out of time. I'll just quickly show you all the work that we've done, mashallah, today. Lots and lots of work. Even though it's the easier part of the paper, it doesn't mean that it's you can smash it out in 2 little bits of scratches and stuff. Lots of formulas, lots of labeling, lots of working out, lots of working out. So you gotta have method, even though you're doing the beginning part of the paper, to ensure that you get maximum marks. Yeah, there wasn't anything that we skipped or we done easily. It was all done properly and took some time. So let's just stop the video there. So we've done the questions from question, is it 1 to 8? So 1 to 8 questions are done so far in this little mini video. And we're gonna stop the recording right now, and then we're going to give you guys homework.